Hey guys, welcome to our today's tutorial. Let's try to look at this question that came in Pharm Chem, which is Pharmaceutical Chemistry 2021 test 1 question, third year. Alright, so here they're saying propose a reasonable mechanism for the reaction shown below. Okay, so this is the reaction that we call as no synthesis of pyro. No synthesis of pyro. Okay, no synthesis of pyro. Okay, so we want to synthesize this pyro. Let's try to propose a reasonable mechanism for this. So I'm going to write this, which is mechanism. Okay, good, like that. Okay, we want to come up with this reaction from which is 2 amino cyclohexanol, and also this one which is called 3-methyl cyclohexanol. We want to come up with a pyro. So the first thing that you're going to have, or the first thing that you're going to do is, since is to see you are using a basic or a base catalyzed reaction, or the one that you want to carry out is the acid catalyzed reaction. So this one is the acid catalyzed reaction. So when you're having an acid catalyzed reaction, the first thing you're supposed to do is protonating the oxygen which is on the 2 amino cyclohexanol. So here the first thing that you're going to do, you've seen that this is like this, then here and to like this. So here I'm going to bring this acid, then here there are electrons. I'm going to grab this hydrogen, that is protonation, you know that. So here this bond, or these electrons will come toward the oxygen there. So what we are going to have is a protonated one. So what we are going to have is the protonated one, sorry. So here to be like this. Get, then here, okay, let me just write it well. So it will be like this, NH2, then here like this, plus water, because when we got this, when we remove this hydrogen, we have just remained with water like that. So that's the first step that you're supposed to do, protonating. So we have this compound now here, which is like that. Then the next thing is to make an enolate ion on the this one, which is called 2-methyl cyclohexanol. Okay, so that's this one is 3-methyl cyclohexanol. Yeah, not 2 but 3-methyl cyclohexanol. So here that's the one that you're going to have, which is like this. So is to make an enolate ion, which is the one that you are going to attack the carbon that bears this, which is OH there, which is protonated one. So what we are going to do is to see the orientation and how the reaction will be. Look at this. We need to see the one that is going to be made as an enolate ion. So here the one that will make as an enolate ion is this. So we're going just to expose one hydrogen and get this water that we formed here, then and get one hydrogen. What will happen to this is all the electrons will come toward the carbon there. So here we are going to have this. Here we have CH3, then like this, then with an acid that will be formed, because we have gotten the hydrogen and we are going to have an acid there. So that's the step number 2. So after that, we are going to get now this, which is so please, you should know how to orient this to have your product. Have you seen how it looks like that? That's the one that I'm going to get it like this, which is then here it will be like this. But this one, it needs to change. I need to change it. So how am I going to change it? It will be like this. This negative, which is an ion, it will be like that. You get? Then this one, it will be like this. Let me put it like this. Okay. Then here, that's where the CH3 is going to be. You get? So I've just changed it. I've just oriented or to rotate it clockwise. You've seen, like the way I've done it. Then you find that this thing, it will be just like the way I've just written it like that. So I need to orient it to look like my product, to come up with the product. So it's the same thing. This one is here, then this one is here, then after here there's a carbon, which is this carbon, then this one is here. Now what am I going to do is to attack this carbon. Okay, show it nicely. To attack this carbon, and this bond will open like this. You get? That's how you show it like that. So here I'm going to have something like this. Like this. So here I can do like this. Okay. I'm going to have something like this. Then here it will open, which will be just OH like this. Then here there will be a bond that has been formed. That is this. Then here it will be like this. Like this. Then here there will be CH3. Then here it's like this. Okay, that's the bond that we have there. That's the one that we are going to use. So remember what we are having here is an OH, which is an acid like that. So we need also to protonate this one. I'm going to get this. This is an acid. This is an acid. Let me protonate it. So these electrons will come and grab this hydrogen, and this bond, or these electrons will come toward the carbon like that. You get? So now what am I going to have? I'm going to have, so here we can show with the arrow. I'm going to have this. Okay. OH with a positive like that. Then here with CH3. Okay, then here we have OH like this. So what will happen when you reach there? You're going to say here, this NH2 here, it has nitrogen has got lone pairs, which will come and attack the carbon that bears this, which is protonated OH there. Then this will open. So I'm going to show you that this one has opened like this. You get? Then what am I going to have? I'm going to have this with OH here. With OH here. Then here it will be like this. Then here it will be N with how many hydrogen? 2. Like this. So now this one is supposed to have 3 bonds, but has got 4 bonds. Here I'm going to put a positive like that. Then here it will be OH. Like this. CH3. Okay, when I reach there, for you to remove these OH here, you are supposed to protonate them, because when you're using an acid catalyzed reaction, OH is a bad leaving group. You cannot remove the OH there. You cannot. So what you are going to do is to protonate it. First, before that, you've seen that here there is OH here. There is 2 hydrogen, and also here there is a positive. So what you are going to do is, first you need to neutralize this charge which is here. Remember what you have here is water. So I'm going to get this water and get this hydrogen. Then when you get this hydrogen, this bond will come toward the nitrogen to neutralize the charge. So what you are going to have, you are going to have this. Here there is OH. Okay, let me just use the other page. Okay, what you are going to have is like this. Here there is OH, then something like this. Then here you have only one hydrogen. Then here something like this. There's also OH there. Okay, when you have this, you're going to say here I have OH. I need to remove this OH. What am I going to do? I'm going to get this. That's an acid. The one that I've produced here. Check. That's an acid because I've gotten this hydrogen. Then I'm going to say this is an acid. I'm going to get these. The electrons will come on the high oxygen will come and grab this hydrogen, and all the electrons or the bond will break and go toward the oxygen like that. So that is now protonated. I'm going to have this. This is now protonated. Here there is OH. So please, I want to tell you that this protonation you can start with any. Yeah, you can start with any. So here, don't forget we have this one, which is CH3, like this one. Okay, that's what we have. So here CH3 like that one. So when you have something like that, just know that you have this water here. You're going to expose one hydrogen there. You know there's one hydrogen there, and you can get this hydrogen and the bond to make a double bond there so that you can remove this water there. So what you're going to do is you have remained with what here after getting this hydrogen. We have just remained with water. So just playing with water and acid. So this will come and get this hydrogen like that. So let me just use another color. So this one will come and get this. Then this bond will make a double bond there. What will happen to this? It will leave. Then here I'll show like that. Then here OH like this. Then here the double bond that has been formed. Then here the CH3. Also you need to protonate this one. So I'll bring this here. It is now an acid. So I'm going to bring this to be now an acid, which is like this. This is an acid. So these electrons which are here will come and grab this hydrogen and make water there. You see, this bond will break and go like that. So you show like that. So what you're going to have, I've seen now I'm showing these arrows. Yeah. So I'm going to have this, which is OH like this. Then something like this. Then CH3. Then here there's something like this. Okay, so I'm going just to expose one hydrogen here. Remember, when you get this hydrogen, for you to protonate it, you have just remained with water. So I'm going to bring water there. So I'm going to bring water, which is like this, and get this hydrogen there. Then this hydrogen will make, or this bond will make a double bond there. What will happen to this OH which has been, or to this water which has been protonated there? It will leave like that. You get? So make sure you are showing toward the oxygen like that. Okay, so it will leave. So I'm going to have my product now. So which is like this. Then here there is like this, something like that. So when you check here on the product, this is the product that we are having here. You get? That's this. You get? So this is how you come up with no synthesis of pyro. First, you know the first one to protonate. After protonating, you have this and water. Then after that, you make an enolate ion. You should know where to make an enolate ion. That's the key part here. And when you make an enolate ion, you have an acid. Then this enolate ion is the one that will be who attack the carbon that has this protonated OH. After that, this one will open. You come up with this. You protonate this one again with the acid that you have. Then after that, this lone pairs on the nitrogen will attack the carbon that has the protonated OH, the one that we've just from protonating. Then this will have a charge because it is now it has now 4 bonds. Then you need to neutralize this charge by getting this hydrogen, attacking the hydrogen with the water. This one will become an acid, and the bond will come toward the nitrogen, and what will happen, this one will be neutralized as it is right now. Then you protonate the N from there. For you to remove this OH, it needs to be protonated to be water, so that you can make a bond, a double bond there, and remove. As we have protonated this, starting this one, it has become water, which is protonated to water. After that, you get this hydrogen and make a bond. This hydrogen, this bond will make a double bond inside, making this water to leave. Then you also protonate that one, just like that. The one that you've started with, the one that you, the one that you, the product to be your, on the first step of your move. That's how it is. That's the preparation of, the preparation of pyro. That is the reaction which is called Knorr synthesis of pyro. Okay, so you should know how the acid catalyzes the reaction, and also how the base catalyzes the reaction. You may be asked in an exam. Thank you so much, guys, for watching this video. Please subscribe.